In this video, we're going to talk about Pythagorean Theorem. So let's go ahead and work through the note and learn together what does it mean and what can we do with it. Our learning goal here is that by the end of this lesson, I will be able to use Pythagorean Theorem to determine an unknown side or sides of a right angle triangle. And so let's start with a little sketch just to make sure we know what we're talking about here. And so I'm dealing with triangles with a right angle. We've talked about those briefly earlier today. And we indicate that like this. So it's a triangle, 3 sides. One of the sides has a little square thing here. That means that those sides meet at right angles. So if one is exactly level or horizontal, the other one is exactly vertical up and down. So they meet at a 90-degree angle. First thing we want to do is define what is a right angle. So let's do that now. A right angle is an angle of 90 degrees. I can't really type that properly, so I'll use the star. Usually we use like a tiny little O to indicate 90 degrees. And it is found when two lines are perpendicular to each other. So lines that meet like this, like one is level, one is vertical, and they meet, that's perpendicular. And I mean they can be at angles, but as long as where they meet, you have that kind of that square shape going on, that's perpendicular. And that means the angle between those lines is 90 degrees. The other term we want to define is hypotenuse. This is the longest side of a right angle triangle. And we'll also mention that it is the side opposite the right angle. Make sure you understand what this means. One of the most common mistakes I see students make with this kind of question is that they mislabel their triangle. They don't have the correct hypotenuse, or they just like pick some random side as the hypotenuse. So I'm going to add a little diagram here to make sure we're clear on which side is the hypotenuse. So let's sketch. Here's my beautiful right angle triangle. Here is my right angle, and this side right here, this is my longest side. Also, if we aren't sure where's the right angle, it's down here. So I look at my right angle and I look across, that's the hypotenuse right there. So let's just draw a little wonderful arrow here. Hypotenuse is going to be this side of my triangle. And normally we don't really bother giving names for the rest of the triangle. If you wanted to, though, I would maybe call the bottom here the base, and then this part either the height or the altitude. I won't really use those terms too often. I might mention it once or twice, but generally basic idea is know where the hypotenuse is, and the names of the other two sides don't really matter in terms of what we're dealing with here. All right, let's take a look and see what actually is the Pythagorean Theorem. Pythagorean Theorem tells us that the square of the hypotenuse is equal to the sum of the squares of the other two sides. And you're like, Mr. Strike, that's a lot of words. I don't know what that means. So that's why we have this nice diagram here. All you have to remember, you don't need to be able to describe it in words. Just remember this formula right here. A squared plus b squared equals c squared. And make sure, and I'm going to highlight this because this is super important, when we label our triangle, the C has to be the hypotenuse. The A and the B don't really matter. And I'm actually going to just change my diagram here a little bit. So we have a triangle, and our question says find the missing side or whatever. Whenever we're dealing with Pythagorean Theorem, one of the first things we need to do is label our triangle. So I'm going to label my triangle with sides A and B and C. C is the hypotenuse, that's the longest one. So that's going to be this side right here. And I said earlier, we can think of the base being the bottom, so we can put B for base. And then we said the other side going up is like the height or like the altitude, how far up we go. And so that can be my A. Honestly, it doesn't matter if you switch the A and the B. If you saw the original diagram before I erased it, the A and the B were switched. That's fine. That doesn't change our answer. But super important, you cannot just change this. C needs to be the hypotenuse. C always has to be the longest side and across from our 90-degree angle right there. Another way to visualize this is like we talk about squared as being just that exponent 2, whatever. What does that mean? Well, it has a physical meaning. So imagine I had my triangle here, and I drew a square on side A, so it has a length of A and a length of A, so this is a square. And I had a square here on the side, so this length is the same as this length. If I took the area of square A here and the area of square B here, it would equal the size of square C. And if you've watched the other video clip I posted with the water, you saw that when they rotated, all the water that was contained in square A and square B drained in and perfectly filled up square C. In my example here, I have a few numbers. You can't just make up random numbers. They have to be the right ones that match your right angle triangle. So I provided an example here of the correct side lengths for a right angle triangle: 3 on the bottom, 4 on the side, 5 on the hypotenuse. And let's just confirm. The size of square A and square B are the area. So 3 times 3 is the area of a square, the area of square A. 4 times 4 is the area of square B. So 3 times 3 is 9. 4 times 4 is 16. And 9 plus 16 is 25. Or if we look directly at square C, it's 5. So 5 times 5, so it has an area of 25. So both of them equal 25. So this is just kind of a demonstration or proof of why Pythagorean theorem works. So if we were to draw a square on side A and side B and add up all the pieces, add up the areas, it would equal the size of a square drawn along side C. But we don't need to write this. We don't need to draw squares every time. We can just go here, a squared plus b squared equals c squared. We can just use the formula, and we can just fill in the numbers that way. All right, let's try a little bit of practice here. We've kind of already talked about this example here, and this is just describing what we already looked at in our previous example. And I forgot to clear my previous writing from this page, so I'm just going to do that right now, and we'll look at this with fresh eyes instead of just looking at answers I wrote 2 years ago. All right, let's take a look at this. When the sum of the areas of the squares on the short side equals the area of the square on the long side, the triangle has a 90-degree angle. So in other words, what they're saying is we can also just measure this. We can check the size of the squares and then prove if our triangle is 90 degrees or not. All right, which of these triangles has a 90-degree angle? How do you know? So to answer this, we'd have to actually get our ruler out. You don't have rulers. You don't have a physical copy of this. I'm just going to tell you the numbers. So let's take a look at our first triangle here. And I've measured the sides previously. So this side has a length of 2. This side has a length of 3. And this side has a length of 2.5. Let's label the sides of our triangle. C for the longest side, B for the base, and A for the other side. Let's see if these add up. I'm going to do a left side, right side check. You haven't done these before? That's okay. What that means is we're going to take a look at the size of C squared, and we're going to look at the size of A squared and B squared. So remember, you can imagine that we've drawn the squares here. Square B, square A. When those add up, are they going to equal square C? Let's plug in our numbers and check. So I want to figure out how big is the size of square C. Well, it's a square, so the area of a square is side times side, so 3 times 3, and that equals 9. Square A, so I'm going to do 2 times 2. And square B, my side length is 2.5, so 2.5 times 2.5. Let's use our calculator for some of this. So 4 plus, switch to my calculator, 2.5 times 2.5 is 6.25. Let's add this up. 4 plus 6.25 is 10.25. So, did square A and square B added together equal square C? No, they did not. And that means this is not a 90-degree angle. So I'm not going to ask you this kind of question too often. It's included in the note, so I think it's good to work through anyway. And so we can do this check. We can find the size of square C. We can find the size or area of square A and B and add it together. And they should be equal if it's a right angled triangle. Because it's not equal, 9 does not equal 10.25. We have proven, and I'll just type this to keep it nice and tidy, therefore this is not a 90-degree angle. And I'm not going to do B and C. This is just a proof of concept kind of thing, just to show you how we can use Pythagorean theorem to test if a triangle actually has a 90-degree angle. Once again, I'm not really going to ask this question again. It's just important for us to try it at least once. This is the kind of question I will ask you, though, where we see each triangle has a missing side length. Find the missing side length. And it says find area and perimeter. We haven't learned about that yet. We're doing this course a little bit out of order compared to normal. So all we're going to do here is practice finding our missing side length. All right, let's see how we do that. I mentioned earlier the first step for Pythagorean theorem is that we need to label our triangle. So let's label C for my longest side, my hypotenuse, which is opposite from the 90-degree angle. B for the base, and A for the altitude or the side. Let's write our Pythagorean theorem. A squared plus B squared equals C squared. And here's where it might get a little challenging for some of you. We need to rearrange our equations slightly. We do almost no work with rearranging equations in this course, but we need to touch on it just briefly for Pythagorean theorem. What side length do I need to find here? I know the length of side C. I know the length of side B. I need to find the length of side A. What that means is that in my equation, I need to get the A by itself. So I want to have A equals something, then I'll plug in my numbers, and then I'll solve. Right now, what's happening with my A? It's being squared, and a B squared is being added to it. So in order to rearrange our equation, we're going to start by getting rid of that B squared. We're going to look for anything that's being added to our A. So I'm going to take my equation, I'm going to subtract B squared from each side of my equation, and I'm going to have A squared equals C squared minus B squared. The other thing I need to do to get the A by itself. So right now there's only one letter on this side, that's good, but it's being squared. I need to do the reverse of squaring, which is square root. So I'm going to switch my color just so we know it's something we're adding on. I'm going to take the square root of each side of my equation. And that's going to give me squared and square root are the opposite, they cancel out, so I'm left with A equals square root of C squared minus B squared. And now we can plug in our numbers. Square root of C squared was 19, so 19 squared, minus B squared, B was 17, so minus 17 squared, and square root. And let's do this with our calculator. Make sure you're doing this in the right order with your calculator. So you can't just do 19 minus 17. Oh, that's 2. 2 squared, blah, blah, blah. It's probably just 2. You got to actually do the steps. So I'll show you on the calculator one piece at a time. So first, I'm going to do 19 squared is 361. Oops. 361 minus 17 squared, which is 289. Then I'll actually do the subtraction. So I kind of recommend, even when I do this on my calculator, I often do this one piece at a time, just so I don't mistype or the calculator doesn't get confused. So I subtract those two numbers and I get 72. And now as the final step, I'm going to find the square root of 72. So your calculator should have a square root button. Sometimes you do the number first and then push the button. Sometimes you push the button first and then do it. It's going to depend on your calculator. You all have different calculators and I'm not physically there to see them, so you're just going to have to try to figure it out as best you can, or even Google how to do square root on iPhone calculator or whatever you're working with. Anyway, I'm using my Windows calculator and I found that the square root of 72 is equal to 8.489. We're going to round to the nearest tenth, so 1 decimal place. So 8.4, the number after it is an 8. We round up, so 8.5. And is there a unit of measurement? No, it doesn't say centimeters or inches or anything, so we can just leave it as 8.5. All right. I'm going to do one more with you, and then I'd like you to keep going on this and try to answer the rest on your own. And then depending on where we are in class, you can check in with me and we'll take some more of these up together, but we'll have to see how it goes and where we're at. So I'm going to erase what I just wrote here, just so I have room to do one more example. And I'm going to do number 2. Step 1, start by labeling our triangle. C is my longest side across from the 90-degree angle. B is my number at the base. A is my height or altitude. Once again, it does not matter if you switch the labels for A and B, but you absolutely have to label C as your hypotenuse. Let's write out Pythagorean Theorem. A squared plus B squared equals C squared. I'm trying to find the C, so I need to get C by itself in the equation, and C's already by itself, looking pretty good, but it's being squared. So I need to undo that. I need to have only the C on that side of the equation. So I'm going to do the opposite of squaring, which is square root. So we're going to take the square root of each side, and let's rewrite our equation. So I'm going to have square root of A squared plus B squared equals C. And it's just C because we did the square root of both sides. Square root and squared are, we call it inverse operations. That means when they come together, they cancel out. We're just left with the C. Let's plug in our numbers. Side A has a length of 5 squared. Side B has a length of 13. And side C, we don't know. That's what we're trying to find out. Once again, I recommend using your calculator and doing this one piece at a time. 5 squared, I can do that in my head, that's 25. 13 squared, I don't want to take the time to do that in my head, so we'll just type 13 squared is 169. All right, next let's add our pieces together. When we're dealing with square roots, it's kind of like brackets when we do our BEDMAS. These are like the brackets, we do our exponents, and now we're still inside like the brackets of the square root, so we're going to do the square root last. We do everything else inside first. So let's do what's inside first. Let's finish the 25 plus the 169. So 25 plus 169 gives us 194. And as our final step, we're going to find the square root of 194. On my calculator, I can just press the button, and there's our answer, 13.9. We need to round. The number after it is less than 5, so we don't need to do anything. 13.9 is our answer. So 13.9 equals C. Is there any unit of measurement? Double check. Does it say inches or meters or anything? No. So all we need to do is say, therefore, the length of C is 13.9. The rest of this note is just extra practice. I will leave it to you to work on it, and depending where we are in class, we can take some of these up together. Otherwise, it's good practice for you to do on your own. So remember, just to summarize, Pythagorean theorem can be used in order to find the missing side lengths of a triangle. Label your triangle, A, B, and C. Write out Pythagorean theorem, A squared plus B squared equals C squared. Rearrange the equation. I know that might be challenging for some of you, but we'll do a little bit of practice together. So whatever letter you're trying to find, get it by itself, then plug in all the numbers and solve.